Welcome to Algebra Prep Academy. Today's lesson is solving logarithmic equations of one variable with two logarithms. We are given the problem log base 7 of b plus 10 equals log base 7 of 22. Solve for b. The log base 7 are on both sides, so they would compare out. Then you would end up with b plus 10 equals 22. You would subtract 10 to both sides because you want all the variables on one side and all the numbers on the other. By subtracting 10 to both sides, you would get b equals 12. By using the check step, you would replace 12 with b, then solve, and you will get log base 7 of 22 equals log base 7 of 22. In decimal form, that's 1.589 equals 1.589. Our second problem is log base 8 of 6 minus 3x equals log base 8 of 5x minus 10. Solve for x. There are log base 8 on both sides, so they would compare out, leaving us with 6 minus 3x equals 5x minus 10. Then we would add 3x to both sides, putting all the variables on one side, leaving us with 6 equals 8x minus 10. Then we would add 10 to both sides, putting variables on one side and constants on the other. That would leave us with 16 equals 8x. Last, we would divide 8 to both sides, so x would be by itself, leaving us with x equals 2. For the check step, you would substitute 2 in for x. You would first multiply, then subtract. This leaves us with log base 8 of 0 equals log base 8 of 0. If it's log 0, that means there is no solution, also because log has to be greater than 0. Our third problem is log base 14 of b minus 10 equals log base 14 of 2b minus 5. Solve for b. Log base 14 is on both sides, so they compare out. Then you will end up with v minus 10 equals 2v minus 5 because log 14 was compared out. Then solve for v and subtract 2v from both sides to get negative v minus 10 equals negative 5. Then add 10 to both sides to get negative v equals 5. Then divide negative 1 on both sides to get v by itself, and the answer is v equals negative 5. Then check the work and add negative 5 and negative 10 inside the parentheses to get negative 15. And in the other parentheses, multiply 2 and negative 5 to get negative 10 and minus 5. Then add negative 10 and negative 5 to get negative 15, and you'll end with log base 14 of negative 15 equals log base 14 of negative 15. And since the domain of a log is always greater than 0, there is no solution because it is negative.